everyone, welcome back to Math Tutoring. Today's lesson is on algebra formula rearranging. So now when you're given a formula, you are asked to solve for a particular variable in that formula. So let's start off with an example. So say we were asked to solve for p in the following formula. So to solve for p, what we have to do is isolate p. We have to get p by itself. So to do that, if you look at this equation, the best way to do that would be to divide both sides of the equation by RT. And when we do that, we get p equals I over RT. And because what we did to one side, we did to the other side of the equation, we're allowed to do that. So that's how you would solve for p. Okay? Try another example. So say you're asked to solve for h. So again, if we want to solve for h, we have to figure out a way to isolate it. So what we're going to do is divide out whatever's in front of it, and whatever we do to the one side, we have to do the same thing to the other side. So then h equals v over 1/3 pi r squared. And then because you have a fraction here, and you've got a fraction, so you've got two fractions here. So this is going to end up coming to the top, and it's going to become 3v over pi r squared. I'm just going to show you how I got that. So I have v divided by 1/3 pi r squared. So that's like v, and I'm leaving the pi r squared, divided by 1/3, which is the same as v over pi r squared times 3 over 1. So you know that in fractions, when we divide by something, then you just change it to multiplication and flip the second fraction. So that's how you end up with 3v over pi r squared, this answer right here. Okay? Solve for w. Now, I want to solve for w, but it is in brackets. So what I'm going to do first is get rid of the brackets. So I'm going to open up the brackets, and when I do, I get 2l plus 2w. The 2 goes into both. Now I want to solve for w, so I want to isolate w. So I'm going to move this away from w. When I bring it over to the other side, it becomes a negative. And now, again, I have a 2 in front of w, so I'm going to divide that 2 out. And whatever I do to the one side, I have to do the same thing to the other when I'm dividing and multiplying. So once we do that, we get p minus 2l over 2, and that is how we solve for w. Okay, we can try some other examples. So we want to solve for u, so we're going to bring that over here. And then to solve for u, we're going to divide both sides of the equation by t. Now over here, as you can see, we have a fraction here. So this is getting a little bit complicated. Now I could rewrite this as s over t minus 1/2 at squared over all over t. So then we get s over t And this actually cancels one of those, and we end up with 1/2 AT. So that would be our answer for U. You can simplify that a little bit further if you want by getting common denominators, or you could just leave it in this form. That would be fine. So, I mean, you could go further, or you could just leave it. You did solve in this equation. Basically, what you want to do is solve for U. It's to get U by itself. So that means it's solved. So let's try some other examples. Okay. Solve. Okay, sorry, I'm just gonna solve for R2. Okay, we want to solve for R2. So right now what we need to do is get it onto the top because it's right now at the bottom. So we're going to multiply both sides of these equations by R1 minus R2. And when we do that, we end up, this one ends up canceling, but the one on the left remains. And then we're going to open up the brackets, and when we do that, we get R1E minus R2E equals PR1. So the E goes here and here. Then we want to solve for R2, so we're going to move that over there. PR1 minus R1E. And then to solve for R2, I'm going to divide both sides of the equation by negative E. PR1 minus R1E. Dividing both sides of the equation by negative E, we'll get R2 by itself. This becomes minus PR1 plus R1E all over E. And then we could simplify this further, or we could just leave it in the following way. Okay. So it's basically just manipulating formulas, so moving stuff around to solve for what you're looking for, basically. You can do a few more examples. But when you're doing that, you have to make sure you follow the rules so you don't solve the solve for whatever you're looking for incorrectly. So say we have solve for R, and the equation is E equals Rn over R minus 1. So we want to solve for R. Okay, so what we're going to do here is multiply both sides of the equation by R minus 1. So we get ER minus E equals Rn. Then we're trying to solve for R, so we're going to bring that over here. So ER equals Rn plus E. Then R equals Rn over E plus E over E. Or we could have just written the whole thing over 1E. Actually, I'm going to take it back one step and go like this. So I'm going to divide both sides by E. Then I get R equals Rn over E plus E over E, which is equal to Rn over E plus 1. E over E minus N. E minus Rn. Okay, so just want to see here if I solved correctly here. So we were solving for R. Okay, so we multiplied R, that's correct, and then bring it in here. Then bring the E over to the other side. Then divide everything by E, which got that following. Yep, so that looks good. Okay, so that would be your answer for R. This one, ER minus E, ER equals Rn plus E, R equals Rn plus E divided by E, Rn over E plus E over E, Rn over E plus 1. Okay. Okay, now here we have a root. The root is covering this whole thing. So over here, first of all, we want to eliminate the root. So what we're going to do is we're going to square both sides of the equation. So then we get I squared equals W over R. So now we're trying to solve for R. So we're going to bring the R up. So it's going to be RI squared equals W, and then R equals W over I squared would be your final answer. So here what we do is we square both sides, and then I squared equals W over R. So to eliminate the root, you square both sides, and then solve for R. So that would be your answer there. Solve for y, and your formula is d equals 2x squared plus y squared. So you're asked to solve for y. So first thing you notice is the root. So to eliminate the root, we are going to square both sides of the equation. And as long as we do the same thing to both sides, it won't change our equation. When we do that, we end up with d squared over here. This square squares this number, and it squares this. So this becomes a 4, 2 times 2, 2 squared. And then when this is squared, it just eliminates the root. So you end up with x squared plus y squared. So then you get d squared equals 4x squared plus 4y squared. And now we're trying to solve for y, so we're going to bring that over here. D squared minus 4x squared equals 4y squared. So we're going to divide both sides of the equation by, let's divide the 4 out first. So we're going to get d squared minus 4x squared all over 4 equals y squared. And then to solve for y, now you have y squared, and the question is asking you to solve for y. So you do need to have this as y. So to get this to be y, what you need to do is take the root of both sides. And when you do that, you end up with y equals the root of d squared minus 4x squared all over 4. Now if you want, you can write this as, this whole thing is rooted, but you can write it as the top rooted over the bottom. So you can write it like this, d squared minus 4x squared all over root 4. So what happens there is you get y is equal to, so root d squared minus 4x squared all over 2. So that's your final simplified solution. Okay, so that's a good example. So you're asked to solve for y, and this is your original question. So just all the steps you have to take to solve for y. Okay? And that is it. So that is formula rearranging.